Hello, lovely student. Welcome to my lessons on repetition. And today we're going to be looking at looping structures with specific reference to the for loop. When would I use a for loop? When the number of repetitions are known. So if I know how many times I'm going to execute a specific task, I would use a for loop. So in Delphi, you can use looping constructs that will allow you to write a set of repetitive tasks once to achieve the same purpose. The most common looping structure is the for loop. Let's look at the concepts relating to a for loop. So in all looping structures, it is very important that we follow the principle ITC. I is for initialize. Variables used in loop conditions must be assigned values before the condition is evaluated. So the variable must first be created. I created a variable called iCount, and iCount then becomes my loop control variable. And that variable is initialized to a starting value of 1. T is for test. The variable created is tested in the loop condition. Example, iCount is less than or equal to 10. So the condition is tested, and that will be the deciding factor of when the loop will terminate. It's all based on the condition to be tested. And C is for change. Statements inside the body of the loop should change the value of the variable used in the loop condition. So in an incremental for loop, the value of iCount will always be incremented by 1. That will bring about the change of the value of the variable. So ITC, initialize, test, and change. The structure of the for loop, or the syntax of the for loop. It starts with the reserved word for. The variable that I've created is iCount, and that is my loop counter. This variable is of data type integer that must be declared before we actually start the for loop in the variable declaration section. My minimum value starts at 1, and my maximum value in this example ends at 10. So it's always your start value to your end value. The start value must always be smaller, so that's your minimum value. And your end value is your maximum value. So the loop is going to run that many times depending on your start and your end value. Note that it ends with do. Do not put a semicolon at the end of do. The for loop has a begin and end block, and we execute statements inside the begin and end block. Then your loop counter variable is incremented by 1 each time that there's an iteration. So each time there's an iteration or repetition of the loop, your loop counter increments by 1. Let's look at it on the flow chart. So iCount starts off at 1. I initialize. My variable iCount is initialized to the value 1. Coming to the condition, I now test my condition. Is iCount less than equal to 10, which is my maximum value. So my condition to be tested is I count less than or equal to 10. Test. The value of the variable is tested to a condition. If it is true and the value of I count is less than or equal to 10, I then execute statement or statements inside the begin and end block. So instructions to be repeated inside the begin and end block. I then increment my counter, C, for change. The counter variable in an incremental for loop increases or increments by 1 each time there's an iteration. I go back up and the value of I now becomes 2. Is I count less than equal to 10? True. It executes the statements inside the begin and end block. My counter then gets incremented by 1. I go back up and I now becomes 3. I then test is I count less than or equal to 10. True. If it is true, I execute the statements inside the begin and end block, and the value of I count now goes to the next value. It increments by 1 until I reach 11. So when it goes to the next value, the loop terminates. So it will only run up until 10. When it reaches 11, the loop will terminate. Do not forget, it starts at a minimum value and ends at a maximum value. These values, the minimum and maximum, or the start and end of a for loop, can be values, it could be variables, or it could be calculations. Do not forget the principle of ITC: initialize, test, and change. Initialize, give it a starting value, test the variable in a condition, and change the loop variable or loop counter increments by 1 each time. So this is an example showing you that instead of using a value, I've created a variable called Imax, and I've initialized Imax to 5. So in this example, and also my loop counter is I. Remember, it's just a variable. You can call it I, you can call it K, you can call it L, you can call it loop. You can call it I loop. It all depends what variable you're comfortable with. So for I is my loop counter variable. I is of data type integer. I is starting at 1 and it's ending at my maximum value called Imax. So this value could be a variable. And all I'm doing is I'm displaying onto a memo that the value of I is, and I'm displaying what the value of I is. Okay, so each time when I is 1, it's going to display 1. It's going to go back up. Remember, it increments by 1. It goes back up. When I is 2, it's going to display 2. It's going to go back up. When I is 3, it's going to display 3, the value of the loop counter variable. When the value of I is 4, it's going to display 4. And then when the value of I is 5, it's going to display 5. When the value of I reaches 6, the loop will terminate and it will execute any statements after the begin and end block when the loop terminates. Let's look at another example. In this example, I've got a counter called iCount, a loop counter variable. My loop is running from 1 to 5. And all I'm doing is I'm finding the power. Power is your base and your index. My base is 2 and my index is the value of I count each time. So when I is 1, my power is going to be 2 to the power 1. When I is 2, it's going to be 2 to the power 2. When I is 3, 2 to the power 3. Okay, so that's what's happening. Each time it's the value of I count. Your sample output would have read each time when I is 1, it's going to display 2 to the power of I count, which is 1. And it'll give you an answer of 2. So 2 to the power 1 when I is 1 is 2. 2 to the power of 2 when I is 2 is 4. 2 to the power of 3 when I is 3 is 8. 2 to the power of 4 when I is 4, it's 16. And 2 to the power 5 when I is 5 is 32. So it's I count that is giving you 1, 2, 3, 4, 5. It's the variable I count that is changing and incrementing by 1 each time, from 1 to 2 to 3 to 4 to 5. Okay, so it's your value of I count each time that is changing. Right, so let's look at the 2 different types of for loops. So we've been looking thus far from the beginning of this lesson at incremental for loops, where we incremented the value of I count by 1 each time. So in this example, I count is my loop counter variable. Remember I said to you, you could use I, you could use K, you could use L, you could use I loop. It doesn't matter what variable you are comfortable with. My start value is always my minimum or my smaller value. My end value is always my maximum value. And each time I execute the instruction, it increments by 1, always by 1. The other for loop is your decremental for loop. In your decremental for loop, we use the command down to. So instead of using to and running from a smaller number to a larger number, in the down to loop, we run from a larger number. So the loop is going to start at the maximum value and run down to 1 do. So using the down to loop, it always decrements by 1. So it decreases by 1. The loop counter variable is going to decrease by 1 each time. So when I count starts at 10, it tests the condition, and then it goes and executes the instruction, and then it decreases by 1, and then I count then becomes 9. It tests the condition, it executes the instruction, it decrements by 1. I count now becomes 8. So in a decremental loop, it decreases by 1 each time. And remember, it starts off at the maximum value and we use down to, and ends at the minimum value. So today we're going to look at a nice activity on timetables. You're going to create a Delphi project. You can call it FRM timetables. And you're going to add the following components to it. A T-edit to enter what timetable you would like to do. So that will enter, for example, I want to do 10 times table, or I want to do the 5 times table. So the user is going to input what the number of timetables you want to do. EDT rows is going to be entered via a T-edit again, and there you're going to put how many times you want this timetable to run, how many rows. Okay, and then you can display on a memo. So the program should ask for the number to create the timetable for, as well as the number of lines to include in the table. The answer should be output to a memo. The memo should be cleared and repopulated every time the button is pressed. Let's go and have a look at a sample output. So if I was doing the user input 12 for the number of timetables and you wanted 7 rows, it's going to run 7 times. And so it's 12 times 1 will give me 12 when I is 1. 12 times 2 when I is 2 is going to give me 24. 12 times 3 when I is 3. Okay, you get the pattern. Okay, so let's go and have a look and code this in Delphi. Okay, so I've got a Delphi project and I've got a button for the for loop. So let's code this button for the for loop. Okay, so all I'm going to do, remember we have to create a loop counter variable. I'm comfortable using I, and remember the value of the loop counter variable is always of data type integer. And all I'm going to do is run a for loop. So to start off the for loop, it's FOR and press your tab key, and that will give you your structure. Okay, let's make that a small letter I. And my I is going to run from 1 okay, and I'd leave that to 10. There's your begin and your end. And all I'm going to do on the memo, I'm going to display the value of I each time. So the value of I is an integer value and I'm displaying on a memo. So I need to make that from int to string. Right, so let's run that and see how it works. So each time when I is 1, it's going to display the value of 1, the value of stored in the variable called I. When I is 2, it's going to check the condition, is the value of I less than or equal to 10? If this condition is true, it comes into the begin and end block and it's going to display on a memo the value stored in the variable called I each time. And this loop is going to be executed 10 times. Let's have a look at it. So all the for loop is doing, when I is 1, it's displaying 1. When I is 2, it's displaying 2. When I is 3, it's displaying 3, up until the value of 10. When it goes to 11, the loop terminates. Okay, so remember, so long as the condition keeps on evaluating to true, the loop will not terminate. It will run into an infinite loop. There must be a value that brings the loop to an end. So when I goes to 11, the loop will quit or terminate. Okay, so in this example, let's go back to our program. In this example, I ran my loop from a smaller number to a larger number, but I used numbers here. So let's see if I had to use variables. So let me just go with I start and I end. And let's give those variables values. Okay, so my start value, I start, I'm going to get a value from a spin edit. Okay, spn start dot value, and I end spn end dot value. So I'm getting values from a spin edit. So now, instead of using a smaller value that's an actual digit, I could now use a variable. So that could be my start value, and instead of using 10, I could use a variable of where I want to end. And then I'm still displaying the value of I each time, but my loop is running from a value that I'm getting an input from a spin edit. Okay, and if you want this to be formatted quite nicely, you can go into Edit, Format Source, and it formats it quite neatly for you. Let's run the for loop and see how it works. Okay, so if I chose a start value of 1 and an end value on my spin edit of 5, the loop is going to run from 1 to 5. Okay, but if I need to clear my memo, because if I run it again, it's going to have the existing values. So what you need to do that is important is clear your memo. So let's go and write code to do that. Mem output dot lines dot add. Now dot clear. And now I can use the procedure clear to clear my memo each time. Okay, now run it and you'll see the difference. Okay, so the start value at 1 and let's go with that at 10. And the loop is going to run from 1 to 10 because all I'm doing is displaying the value of I each time. Let's give it a different start value. So if I had to start at 5 and I wanted to end at 10, let's see what happens. The loop is going to start at 5 and end at 10. Let's give it another start value. So let's say I wanted to start at 10, but I wanted to end at 20. So it's going to start at 10 and end at 20. Okay, so what if I wanted to only execute the loop 3 times? I wanted to start at 1 and I wanted to get a value from a spin edit. You can do one of two things, enter that value, or you could use your spin edit scrolls to get the value. So all this is going to do is going to start at 1 and end at 3 and execute 3 times. And that's what it's doing. Okay, it's really a lovely loop to use if I want to perform fixed repetition and the number of iterations or repetitions are known. So the second loop we spoke about today was the down to loop. And we called this the decremental loop. So I'm just going to quickly write some coding to show you how that works. So again, my loop counter variable, which is of data type integer, and for and tab on your keyboard. I want to start off at but remember in the down to loop, it's going to go from a higher number, and instead of using 2, I'm going to use down to. Okay, so instead of using 2, I'm going to use down to. Note that the command changes color as well. Okay, and all I'm going to do again is display the value of I. Let's see how that works. Remember that even here I could select a start and end value and use variables instead of using actual digits. Okay, so I want to display the value of I, and remember I need to put that in brackets and say int to string. Okay, so let's run it. Remember, with the down to loop, it's going to start at a larger number and end at a smaller number. Right, run that. Let's see how that works. Okay, so using the down to loop, it's going to run start at 5, but decrement each time by 1. So when I is 5, it's going to display 5. It's going to decrement by 1, and I goes to 4. It displays 4. It decrements by 1 again, and I goes to 3, and it displays 3, and it ends at 1. So that's your second type of looping where you get the decremental for loop. Okay, so let's go and look at and play around with two quick examples that I've created for you. The first one was the power example that we did. Let's go through quick the coding on that. So I've created a variable to start and end my loop. I'm getting two values from a spin edit. Okay, dot value, I'm getting a value from a spin edit for the start and end value. So I'm running my loop using variables, a start value and an end value. Those are the variables that I'm going to be using, that I've used here and got values from a spin edit. I'm then finding the power. If my base is 2 and my index each time is going to be the value of I, and then all I'm displaying is that 2 to the power of whatever number is I, and I'm getting an answer. Okay, so let's run this and see how it works. Okay, so if I put my start value at 1 and I want to run it 5 times and my end value at 5 and I'm using power, so when I is 1, it's going to give me 2 to the power 1 is 2. When I is 2, it's going to give me 2 to the power 2 is 4. When I is 3, it's going to say 2 to the power 3 is 8, and so forth. But it all depending on what's your start and end value. Okay, so let's look at one more program, and this is quite an exciting program. It's the one on timetables. So all you are doing is to enter what timetables you would like to do and how many times you want to execute that, how many rows do you want. So let's look at the timetables. So I entered the number of what the timetable I want using a t-edit and how many rows using a t-edit. So I'm running my loop from 1 to the number of rows. And then I'm taking inum, which is, so if I want a 10 times table, it's going to say 10 times when I is 1, and it's going to be 10 times 1, and that will give me a value. Then I go back up and I is 2. If the number entered was 10, it's going to go 10 times 2. Sorry. If the number entered was 10, 10 times when I is 2. Okay, 10 times 2, and it's going to give you the calculation of 10 times 2. So let's run this and see how it works. Okay, so let's say if we wanted 12 times table and I want to run it 12 times. Okay, so it's going to read, remember the value of I is changing each time. I is 1 and I is 2, I is 3, I is 4, I is 5, and so forth until it reaches 12. Remember I stipulated I wanted 12 rows, so it's going to execute 12 times. And this is the number of the timetables I wanted. Okay, so it's running from 1 to 12, that is the number of rows, and it's giving me 12 times table because that is what I wanted. So 12 times 1 is 12 and 12 times 2 is 24, and this is going to execute 12 times. That brings me to an end on the introduction of for loops. Thank you, students, for listening. Stay inspired, stay motivated, and follow me on my next video.